Hello everyone, myself Dr. Manoj Kumar, working as an assistant professor in Department of EC at MLR Institute of Technology, Hyderabad. Today I am going to deliver a lecture talk on digital phase meter. This is basic overview of my presentation. First of all, I would like to discuss the concept of phase meter. Thereafter, I will be taking its classification, construction, working principle, and finally some of application of digital phase meter. So first, we will try to understand what is phase between two signals. It is nothing but the time lag between two signals is generally denoted by phase difference of two alternating signals. So digital phase meter will calculate the phase difference between two signals. Purpose, it ensures the accurate phase alignment in electronics and communication system. So the work of digital phase meter is very important. It is used in the electronic and communication system for the proper phase alignment. Classification. Based on the input signal, we can classify the digital phase meter as a single channel and dual channel. In single channel, we can measure the phase relative to the reference. In dual channel, we can compare two independent signals. Based on the application, we have low frequency meter used in the audio and power electronics, and high frequency phase meter which can be suited for RF and microwave system. So based on input signal and its application, we have done the classification of digital phase meter. So some of the basic components of digital phase meters are signal conditioning circuit, which prepares the input signal for processing. Then we have zero crossing detector. Identify the points where the signal will cross the zero voltage. It is a reference point. Then we have microcontroller or digital processor that calculates the phase difference. Then we have display unit to show the phase difference in degree or radians. And to ensure the functionality of electronic component, obviously we have to apply the power supply. Additional features, we have built-in calibration circuit and memory for data storage. So these are some additional feature of digital phase meters. So in digital phase meter, we can see that some amplifier and attenuator combination circuit is there, which will amplify or attenuate according to the nature of signal. Once it is amplified and attenuated, it is passed to zero crossing detector. Zero crossing detector will serve as a reference point to trigger out the JK flip-flop. So two signal coming at different time delay, whoever trigger first, the AND gate is activated and clock started. And in this way, we calculate the delta T between the two signal. So we have pre-amplifier, zero crossing detector, which will convert the sine wave to the corresponding square wave, and once it is converted to square wave, it will trigger the JK flip-flop, which is directly connected to AND gate, and here clock is there, for clock is attached to the AND gate, which will act as a reference. So in this way, what we'll do, we can easily calculate the delta T, means time delay between two signal. So basically already I told that phase difference is nothing but the time delay. It is the generally time delay between two signal. So what is the working principle? The first of all, the meter will receive the two input signal. The signal are processed and passed to the zero crossing detector, which will convert it into the square wave. That once it is converted to square wave, the time difference between two signal are calculated based on the activity of JK flip-flop and clock attached to the AND gate. So once the delta T is calculated, with the help of formula, we can easily calculate the phase difference between two signals. So using this formula, we can calculate the phase difference between two signal. Delta T is the time delay between two signal and T is the time period of signal. So already we discussed that input signal is passed through the amplifier and attenuator circuit, which is nothing but the signal conditioning circuit. After that, zero crossing detector. Thereafter, through JK flip flop, we are able to calculate the delta t, and with the help of formula, we can convert delta t into the phase difference, and finally, the results are being displayed on the LCD. So these are some of the application. Digital phase meter, widely used in the power systems, communication systems, radar and navigation, ensuring accurate phase detection in signal processing. It can be also used in audio engineering, maintaining the phase alignment in the stereo systems, and it is also used in the research and development for testing and calibration in laboratories. Thank you.